I'd like to welcome you all to the first ever New York City Temporal meetup. We did have a meetup last November in this office, and that was Temporal sponsoring Go NYC. But this is the first Temporal only meetup. And I'm planning on organizing more of these, maybe starting in January, every other month. So we welcome you back in the future, next year. Bring your friends, bring your colleagues, whoever uses Temporal or whoever you would like to come drink the Kool-Aid and learn about Temporal. You can also contribute by speaking if you'd like to. Please let me know. You can present a talk or be interviewed about how you use Temporal and help spread knowledge. And I wanted to, I guess, set context by saying that Temporal was the software and the company were both created to improve the lives of developers. That was why Maxim left Uber to start the company, to be able to improve the company and spread the word. And part of improving the lives of developers is building community. So that's why we're here tonight, to meet each other, meet more people using Temporal, and get to know them and learn from them, and then also learn from the presenters. So please feel free to introduce yourself to everyone else. That's why we're here for this meetup, to meet people. I want to give you a thank you to Datadog for the space. I am getting called by the pizza people, so whoever has my phone, Cozy, you got it. All right. We're going to take a break in a bit once the pizza is ready. So Datadog is a popular monitoring and analytics platform. I asked ChatGPT, what is Datadog better than? And it says, Splunk. Datadog is less expensive, easier to set up, more focused on the cloud and container monitoring. Better than New Relic, offers better log management, more integrations, and is generally more user-friendly. Better than Prometheus, more out-of-the-box functionality, easier to scale, doesn't require manual metric configuration. Better than ELK, which for those of you not familiar with log analytics is Elasticsearch Logstash and Kibana stack. Easier to manage, Datadog, less resource intensive, and better alerting features. And the unique strengths of Datadog are unified dashboard, all metrics in one place, turnkey integrations, over 400 integrations, including Temporal Server, check it out, and real-time alerts, highly customizable. So thank you to Datadog and ChatGPT. The bathrooms are down this hall and then on the left. If you ever need to get up, please feel free to go there or grab drinks. We have wine in the back, non-alcoholic beer, and then pizza coming. And the schedule today is starting out with Maxim, our co-founder, talking about durable execution and event-driven architecture, followed by Alan George from Datadog, talking about Datadog's Workflows product, which was built with Temporal. And then we have a panel with Maxim, Alan, and then Lenny Bloom from JPMorgan Chase. And then finally we'll have a happy hour with more drinks and pie, different kind of pie, the sweet potato and pumpkin and apple pie. So I'm looking forward to meeting y'all, and I'm happy you're all here, and I'll hand the mic over to, actually, wait, no, I have more things on here. Thank you, Jim. Multi-region availability, currently private preview, so if you're a cloud user, talk to your open support ticket to get added to the private preview of this. It's so that if the entire region goes down that you chose to, AWS region that you chose to host your Temporal cloud in, we can fail over to a different region so that you can continue running your workflows. We also have Temporal 101 and 102 courses in a number of different languages. Check out this QR code. I think it's the best way to learn Temporal. And then we have talks from our Replay conference that we hosted in Seattle this year. And we have a number of the keynotes out and more coming out every week. And that, I'll hand it over to Max.
Can you hit it? Oh. Yep. Okay? Yes. Great.
Let me run this thing.
Cool. Do you know what it is? This is a map of solar system, but this map is a Earth in the center. So this obviously is very simplified, but this is how planes move. Like if you put Earth in the center. So very nice, but complex. And as you know, in the beginning of 16th century, Copernicus kind of changed the paradigm. They put sun in the center, and trajectories became same. In real life, the ellipse, like they're certainly not circles, they're ellipses, but idea is that just changing the paradigm, like kind of point of view, you completely change, kind of reduce all this complexity. One thing I want to mention is both of them are correct. I have a degree in physics, so I kind of know that all frames of reference are the same. So it's not like one of them is more correct than the other. It's just, you know that if you take the right frame, it's just simpler, right? Your life becomes much simpler than if you take the wrong frame. And if you are thinking about like satellites orbiting Earth, probably putting sun in the center would be a weird idea. So how does it relate to us here? We deal with a lot of complexity. We, as developers these days, almost everyone, when we do backend applications, we write distributed applications. And the moment we go beyond like simple request reply and short requests, we are in the world of perfect world of queues, events, and everything. And like it's a lot of complexity. And the question is, how do we deal with that? And my claim, which is that we just took the wrong point of view. Event is the wrong center. If you think about your system, a system composed of events, queues, and so on, it's other technologies we deal with events. You are putting the wrong thing in the center, and you deal with a lot of complexity as an engineer. And it makes your life harder when you develop software, and it makes your life very hard when you support that. So let me spend some time on event-driven architectures and trying to explain what I mean, why you don't want to use them as a kind of core abstraction. First thing is that the moment you switch from like request reply, like normal RPC to event-driven system, you lose APIs. Like your service doesn't have API anymore. Because I consume some messages, you know what? I can publish some messages, and yes, there is API spec, I know about that. You can specify format of the messages, but it's still not an API. It is just, especially if you don't know who's consuming your messages. So I think this is very important because there is no good API specs for like asynchronous services. Other problem is that it's pretty obvious that logic of your system becomes scattered. Like even just determining sequence of execution of certain operations becomes practically impossible. And then you need to do things like compensations, cancellations, and so on. It becomes practically impossible. You practically need to run the system to make sense out of that. You cannot just look at the code and like, yeah, I know what's going on. Like just look, you really cannot make sense out of that, especially if it's scattered around. It's super hard to understand. Other thing is that it's not just queues, it's not just events. Every service becomes an ad hoc state machine because it's not just about receiving an event and publishing an event. You practically need to publish events based on your state. And then these state machines, probably all of us wrote one, it become, usually we start at hoc. You just like read database, take message, update database, publish message. By the way, not many people implement out-of-box patterns, so usually there is a race condition between publishing message and updating the database. Most people just ignore it, like I work with Uber, people ignore it. And like SU salary especially, right? Like just norm. Like, yeah, sometimes things fail, sometimes people just call and say, where is my click? So that is another problem. And also, event-driven systems are highly coupled. And I'm pretty sure you've heard the opposite, right? Like, the first thing you learn about event-driven systems that they are loosely coupled. This is the best thing about them. The problem is that people absolutely confuse two things. They are loosely coupled at runtime, right? Because the nice property of any like queue-based system is that some service can be down and you still can operate. You can publish messages, you can consume messages from queues. So there is no like direct dependency between runtime characteristics of different services. But it doesn't mean that they are not coupled at the design time. And yeah, the first thing you hear is, no, it's super cool. You can add new service and will consume messages, and other services don't need to know about it, right? It's awesome. Just it's very easy. You change your system all the time, and you don't need to change other places. I can give you an analogy. Imagine you are doing, somebody comes and says, okay, I want to improve your service, and I'm going to change all variables to global variables. Like, why? Because I want to make it like less tightly coupled. Because you can add new piece of code that reads the all global variables, and you need to change all the other pieces of code, right? Because it's just, but we use exactly the same logic for events, right? Like, and I don't know why people don't understand that. Like, we should very clearly say, event-driven systems practically make your life miserable because you can change one message format and you have no clue what's broken, right? And I witness that at Amazon all the time. Like, people just shit scared to change their code because they don't know who's going to be affected. And I'm not talking about, and there are subtle things. You can just change order of messages without any format, right? Or like things get reordered, or things are published with wrong queues. And I think this coupling is a very important misunderstood thing. Yes, at runtime, event-driven systems and asynchronous systems in general make your life better and easier. But at design time, any async system and always distributed systems is much, much harder to do. And latency, then you have a bunch of queues and you go for that, and just latency usually is a problem, especially if you try to come up something which is interactive. I've seen people suffering big time trying to kind of make 5 Kafka queues to respond within a second, for example. So, if you put an event in the center as a role abstraction, what's the right abstraction? Probably you might guess that my answer is very simple, durable execution. And so if you think about your system not from as a composed of queues and events, but composed from workflows, right, from queues, from what we call durable execution, your life becomes much simpler. So let me spend some time on that. So first, not all of you probably heard the term durable execution. This is a kind of, we think it's a new abstraction because it's not something they teach us in school, but I think it's important as an abstraction. Don't even think how it's implemented, right? And the idea is very simple. You just have a runtime which will preserve the state of the code all the time, right? So if you're running your code, you're blocked on some line of code, and process crashes, machine goes down, data center disappears, power outage. But the moment things come back, or like new machine is brought up, we recover the full state of that process in exactly the same state with all local variables, blocking calls is still blocked in the same API call, and then 5 days later when reply comes, it will continue executing. Very simple concept, but I don't think that we can find in any book this concept described as a kind of concept how you would write your software. So I think durable execution allows us practically completely rethink and redesign your software and think it is in this context. So going back to the event-driven architectures, one thing which a lot of people who use Temporal don't realize that internally Temporal is completely asynchronous system. It's absolutely based on events, right? So every time you do something, there is a task queue, there is a like transfer queue, there are events, like everything is fully asynchronous. If you look at SDKs, even if you block on like sleep 30 days, this thing immediately unblocks, right, and sends events out. So it's all asynchronous. But your experience is not, right? Your experience is based on a durable execution. You get nice experience which allows you to just write your code. But you get all the runtime benefits of asynchronous systems. So I'm not saying don't use event-driven systems. I'm saying don't use them to write your software. So if you use Temporal, you are using an event-driven system. You're getting all the runtime benefits of that. You can scale out your workers, you can you have backlogs, you get all the benefits of queues. Even more because we allow things like infinite retries and so on, we can talk more about that. But the idea is that, yes, I'm not saying don't use them. Don't use them to design and write your software. And this is exactly what Temporal is about. We didn't invent any new distributed system algorithm, right? We didn't come up with some a fancy, leader election thing. We improved developer experience. The only big innovation of Temporal itself is a new developer experience. But this developer experience based on this durable execution allows us to hide all this complexity of existing distributed systems under this very, very nice abstraction. That is kind of core idea about Temporal. if you explain somebody, no, it's not like new algorithm or whatever, it is new developer experience. And it's pretty simple idea, but it allows us to hide all this complexity. So obviously Temporal is not just event-driven system, it has all these other things. But durable execution is the core developer experience, and then we can go and add different things. I'm not going to spend time on every bubble here, you probably understand all of that. I think important thing is that first we have SDKs in every language, right? Like at least not every language, but we have 6 now officially supported. There is also Ruby contributed by, I think, community. And then there are some exotic ones which I'm not even like. I think there is Scala, there is, what's this functional language, which is Haskell. It was actually pretty high quality Haskell SDK based on our SDK core. So I'm pretty sure community will contribute more. So that is one important thing. And the other one is that besides obviously being secure and all these other things, I think scalability and availability are important. Because if you have nice developer experience, but this thing doesn't scale, and we've seen a lot of solutions like that, right? Like they work until they hit the wall. And with Temporal, not because we are so smart, just because we took us 15 years and multiple iterations, but we kind of, when we were building Cadence and then Temporal, we designed it as a highly scalable kind of system out of the box. And it practically allows you to get this awesome developer experience when you start, like you're a small startup, like 1-2 people, you move faster if you use Temporal. But if you become successful, like you absolutely can scale to almost any rates without changing the line of your code. And I think this is the main benefit, and that's why, for example, a lot of startups using us, and they're super happy about that. And there are some startups which actually took off, and like their rates are actually very, very high. Which makes our business happy. But at the same time, they just focus on their like being successful and not thinking about infrastructure. So I mentioned both workflow and durable execution interchangeably a few times. I just want to make sure that we're on the same page there. When anyone from Temporal says workflow, we mean durable execution, right? Which is like code written in high-level programming language and has this runtime which recovers state. Problem is, when you talk to people who have no clue about Temporal, and you say workflow engine or workflow, you lost them, right? It's not ML, right? It's not like artificial intelligence. Workflow is something which people are like, okay, I don't want to hear about that, right? I'll do queue, I do whatever, because this is not technology I want to bet my life on. So I think when you talk to external people, just be careful. Explain them durable execution, explain the idea, and then say, yeah, for legacy reasons, if you say workflow, we mean durable execution. Because I've seen that, because I've seen people say, oh, I found this nice temporal thing, it's like workflow engine. And like, okay, I don't want to hear about that. And that is very important. Like, explain durable execution, explain the concept, and then we can call workflow activity and all these kind of standard names. But this is something which I think important to understand. Try to explain, because I don't think a lot of engineers will be very super happy like just learn about another workflow engine. And we know why, because existing ones just don't provide the experience you really want as an engineer. So, nice thing about workflows and durable execution is after you kind of get to some point, I don't know how many of you are already there, but I hear it all the time. After you kind of get familiar with Temporal, you implement a few things in production, then you realize that almost everything you're doing is workflows, right? Like half of your application backend should be rewritten as workflows, so at least could be rewritten as workflows, right? I hear it all the time. Oh, why I didn't have that when I was doing my last startup? I would write everything as a workflow. And I personally think it's a good thing. It doesn't mean that you need to use Temporal when it doesn't fit, right? There are cases when it doesn't fit. But I think at least considering that it's a different way to think about it, but considering Temporal as a kind of as abstraction, durable execution abstraction, I think it's very important because it will allow you kind of think very differently about your program. But yeah, don't get scared. I've seen people practically, if you think about a lot of companies, not every company, but in a lot of companies, probably 80-90% of what they're doing, besides maybe big data and ML and like artificial intelligence, the rest is just a bunch of workflows. And that is very common. So I don't want to make it a very long talk. I just kind of want to reiterate the same thing, is that a lot of complexity in our software right now is not inherent. It's not related to our business logic. It's not related to kind of directly to our complexity of our application. It is incidental complexity because we just use wrong abstractions. And if you stop thinking events and start thinking durable execution, you start thinking temporal, your life as an engineer will become much, much simpler. Okay, that's it. Any questions? Okay, okay.
Explain the use cases where people shouldn't use it.
Huh?
You talk about the use cases where people shouldn't use it.
Oh yeah, the question is, what are the use cases when people shouldn't use it? Oh, there are no such. But no, reality is very simple. It's not about vertical. It's not about even use case because people try always. Oh, do you do this or that? It's more about first question I always ask: what type of guarantees do you need, right? Like if you're making a RPC call, it calls a bunch of other services, and then any of them can return 500, right, or error back, and you propagate error back, and there is no consistency issue on the back end. You don't need temporal, right? Just do normal RPC. Or if you your machine can lose state, like so if it crashes, and you can redo the whole thing from the beginning, and nobody cares about that, you don't need temporal in most cases because there is overhead because we use persistence. But every time you say I need guarantee of compensations. Even if it's short-lived, it's not about duration, right? There are a lot of people using temporal under 1 second workflows, but they know that they run compensations, like payments, almost all instant payments fit that, right? If you need compensations, if you need guarantees, if you need guarantee of completion in presence of different failures, then temporal is usually a very good fit, and it will perform probably the same or better than like even handcrafted solutions. Because anything handcrafted which requires these guarantees will still talk to the databases, still talk to the queue and all these other things. So yeah, it's all about guarantees and reliability. What's our question? Yeah.
Would you ever consider hosting the workers on your cloud?
Question is, did we ever consider hosting workers? Absolutely. We consider it. A couple of things. Tell the truth, as a business, we need to grow. And so far, I didn't see a big company, like really big company, which came to us and said, you know, we are dreaming to host our precious code of our business logic in this small startup, like a data center, right? Even if it's like the VPC.
Yeah, but small companies don't care.
Right. So by the way, things we are considering, there are obviously no promises there. For example, we prototype Lambdas, right? Amazon Lambda. And the cool thing we can do with Amazon Lambda is that we can treat Lambda as a practically host, up to 15-minute host, right? And we can practically run Worker there and cache workflows. So a single invocation of Lambda can run thousands of activities and thousands of workflow tasks, cache workflows up to 15 minutes. So practically, if you do it right, you can get very, very high utilization of these Lambdas, much cheaper than per Lambda call, and host practically have full hosting. I'm pretty sure we'll implement it one day. When exactly it will be happen, I'm not sure. We can do naive way. It's very easy to just invoke Lambda on every workflow task, for example.
Yeah, I've hacked something together myself, but I was wondering if there would be.
Yeah. No, that is something we should absolutely consider. Okay. Longer term, things like WebAssembly are possible. A lot of other things are possible. We use V8 to run our TypeScript SDK, so we could host those things. But the reality is, from practicality, that the fact that company runs their own code in their VPC and only uses temporal backend server as a hosted version of that is a major advantage when you talk to security. So there is no very much pressure. But for example, if community wants to, but it's not simple. To do it right, we talked about that. If you want to do it right, it's not a small project.
No, it's not. But
Yeah.
it's just an adoption for someone small.
Yeah.
It's kind of a big deal. Having a separate worker then.
Yeah.
If you're a big company,
just to repeat, it's for adoption is good. Yes, I agree. It's a priority thing. But yes, we prototype and we have people who are very passionate about it within the company. Right. And we have cases when passionate people convince us to do things even if they are not seen it's super important for the business.
Great.
Yes.
What facilities does Temporal have for running activities in different languages? Can you
run activities in different languages?
Different languages within the same workflow?
Yes, it's already supported out of the box. We actually have samples. I think there are a couple polyglot samples. I think there is one sample when you have like 3 or 4 languages.
Nice.
Activities and workflows and child workflows, all of them can be different languages. There is no any dependency besides, by default, you serialize arguments into JSON. If JSON structures on input and output are compatible, these things just work out of the box. Ping us on Slack. I don't know if all of you are on Slack, but join our Slack. And we can always send you like a link to the samples.
Great.
That's t.me/slap.
Yeah, on the event-driven architecture slide, you mentioned loose coupling as kind of a false advantage of that because of the build time dependency versus runtime coupling. Can you talk a little bit about how Temporal does or doesn't provide for looser coupling between services?
Question is how Temporal provides for most loosely coupled services. I think Temporal, think about Temporal as RPC, right? RPC is more loosely coupled in the sense that there is API, right? So for example, if you have a service, it has clear input, clear output, right? So it means that you know, when you call the service, you map arguments yourself, you know that it will be there, right? And like you cannot like go and change something in my service which will break this service, right? In the event-driven system, because you don't know who's usually consuming messages in what format, it's very easy to break. Temporal is technically RPC, but the difference is that single RPC can take days, right? It's an RPC-based system, but for long-running, potential long-running. They call them ALO, arbitrary length operation. So it can be short, but it can be very long. And that is kind of a big difference, because everything has an API. It's very different, for example, it's also comparing to most existing workflow engines out there which use configuration languages, right? Most of them has just one map, right, to pass data around, like BPMN, for example. Again, I'm not expert, maybe correct me if I'm wrong, but what I've seen in examples, like a task puts something into the map, and another task reads something out of the map, right? The cool part is that like picture doesn't show that, right? So practically, when you're consuming something from some map, you really don't know which task put it there. So it's like a bunch of global variables again, and people don't realize those things. Like these systems become very brittle. But in Temporal, every activity, every child workflow has a very clear API, right? It's just like in Java, it will be just interface. Like in Go, it's also kind of similar thing. But idea is a function, right? But so with input-output arguments is pretty much simpler. That is kind of basic idea. Sorry. There is one back.
Thanks for the presentation. So you mentioned how some of the complexities is a matter of your perspective and paradigm, but I guess in this case it's not just your perspective of the solar system. You have to implement the solar system because it's still the same motion. So I guess won't that have felt daunting, because you also acknowledge that there's events under the hood. So like, I guess how was the approach of thinking about the complexity to implement all these primitives and actually deciding to undertake it, because like you said, your inputs are expanding to more and more languages. And, I guess how's that process of implementing Temporal?
I guess first thing is that yes, all this complexity is there, but Temporal took on that complexity for you, right? And it means that you write your workflows, we do asynchronous systems. It just took a lot of iterations, right? So just to give you some history, it's based on, first idea came out in simple workflow service, right? AWS simple workflow service. It was publicly released version I was tech lead of is the third version. We had 2 previous versions inside of Amazon. Then co-founder of Temporal, Samar, build durable task framework at Microsoft. So Microsoft has Azure durable functions based on the same idea. And then we built this cadence thing at Uber, and then we built Temporal as continuation of that. So just that is over 10 years, probably 12 years of just code iterations. And I can tell you, it's probably thousands of discussions, like days of discussions. And Temporal itself, we are a relatively new company, 4 years in as a company, but the code base is 7 years in production, right? It's hundreds of man years invested in just writing code. I'm not talking about design and testing. That's why when people say I can write my own job queue, yeah, you can. You have 200 man years to make it. Like it's the same as writing database. Everyone probably can write relation database. But why would you, right? You can just take something which took like hundreds and hundreds of man years to make it production worthy. Are we okay on time? Because I can go for a long time. Who's controlling time? Guys,
I think we're fine.
fine? Okay, let's go. Yeah.
You talk about Temporal being an execution engine which is effective for arbitrarily long executions. I'm wondering, how do you square arbitrarily long executions with change management? Because systems evolve quickly. The business logic, the code that we're executing in Temporal itself can change. I mean, how does that interact with very long executions?
Yeah, so how do we update workflow, like the system and workflows, right? So Temporal itself, we guarantee compatibility of updates, right? So you always can, if you open a cluster yourself, we guarantee that you can deploy a new version and you can roll back if something goes wrong. So we kind of guarantee roll back one version back. You cannot skip versions, right, when you deploy because of that. But we guarantee like uptime and it's like seamless upgrade. But from your logic point of view, okay, upgrading long-running process is not trivial. There is no like generic solution for that. We have our solution is that you can version code while workflow is running. It's not pretty. You need to practically put branches in your code, like saying if old version, old code, if new version, new code, and then we have API to determine if old code is kind of not used anymore, and you can delete that. That is kind of approach. We have new feature when you can version the whole workflow, right? So it means that when you started, you pin the version, say version 1, and then you can say now version 2 is active, then you pin version 2. It helps when you have not super long workflows because you need to run workers for kind of both versions. But if your workflow is like up to a day, or if you're doing payments like up to a few minutes, it's a perfect solution. But we kind of recommend both, right? Like do opinion version and for not very long workflows. And then if you need to patch workflow, we call it patch now, right? For like bug which should be patched for already running workflows, then use this other mechanism. I would love to have more generic solution for that if anyone has ideas. But getting like a random piece of code with random state and converting to other random piece of code with random state is probably not very feasible in general case. So far, I know one thing I would recommend, if you use these mechanisms, always have unit tests because you can do node histories in Temporal, like from and save them to the file and make it part of your unit test. Practically, we have replayer component in every SDK, and you can replay a bunch of workflows while you're doing unit test. And means that if you broke your compatibility for whatever reason, like your unit test will fail. And then other thing, when you do upgrade test, like you do testing of new version of your code, always do upgrade testing. Never do like, some people do, oh, it's CI/CD, I will create like new version, run my new code, all good, right? Always start workflows on the old version, right? Let them run, or like make system like execute, and then do upgrade of your workers to new version, and make sure that nothing is broken. At Uber, our team had alarm on the dev environment, practically dev environment for like workflow task failures, for non-determinist failures, because we knew if there is even one failure in test, it means that somebody probably rolled out the change which is not compatible, and we would be patient, like go to that team and say, make sure you don't roll this to production. So yeah, this is obviously probably the worst part of the Temporal, let's say this way, right? But at the same time, how many technologies allow you to have a wrong running process and upgrading? Like event-driven system upgrading in while flight, it's like practically your own completely. Yeah.
This is really cool. Thank you so much for presenting. It seems useful, like at the application layer, for operations that aren't deterministic or idempotent, the same way that like transactions are useful at the database layer as an abstraction. Wondering, could you talk a bit about scale and performance in the context of problems that have like strict data consistency or ordering requirements?
Yeah. So, like the core idea of like limitation of approach we took is that single workflow has limited throughput and limited size, right? You cannot have single workflow which will take 100 requests per second and process them, right? We scale out this number of workflows. Right, so you can scale out practically infinitely this number of workflows and number of actions per second if you scale out number of workflows. So if you're trying to build system which requires like, oh, I will have one workflow, it will synchronize with queue with like a lot of requests, it's a bad pattern. Don't use it. Like when you shouldn't use it, right? At least this way. But if you have a use case like Uber, like you have hundreds of millions of users, And each user rate of updates, like you cannot take like, I don't know, 50 Uber trips per second, right? But across all users, it's a very high rate. But each user is relatively low rate. This is the like perfect fit for Temporal. And then for those use cases, we provide pretty good like latency and everything and throughput. Like the best, at least on for our cloud, because we need to scale a lot, we wrote our own database practically, right? This database, the reason we could do that, because writing database is insane these days, because we write a database for a single API call, right? Like practically one API call is practically the core of Temporal execution logic. And we know how to optimize that call like very, very well. And we wrote database just for that single API call. And there we can we had test which we call MPS, right?
Yeah.
MPS, million per second, right? Paul was like leading the team, the idea was that you could do million state transitions per second, right? Which kind of roughly corresponds to 300,000 actions per second, which would say like 300,000 activity executions per second. And we could go higher, it just was an AWS bill we didn't want to pay for a long time. But we didn't find any things we couldn't go higher. But yeah, this can scale to, I don't know how many businesses require 300,000 like activities per second, unless you're doing like ads or something really crazy. Every time we have anyone doing some physical things, or we are bank, we are doing real payments, right? Humans doing payments, or we are like doing orders, or we are doing whatever. It almost always ends up very low rate for us. But because system was kind of built by design. If you're interested a little bit more to look under the hood, there is a presentation of me. If you Google my name, and I think it's building workflow engine from first principles. This is the name of the talk. If you just like building workflow engine from first principle, Maxim Fateev, just Fateev. It's kind of cool to have a rare name in America. I just a random thought. Once I called the bank and said, you know what? I'm trying to create an account, and this account is taken. It's me. Like I'm 100% sure it's me because I'm the only one who create account with this login. And bank like, are you crazy? Like, doesn't make sense. Like after 10 minutes, I convinced them they reset my password, everything went fine. But yeah, having a real name is kind of cool.
Was it your account actually?
It was my account, right? I created 4 years ago or something, right? Yeah.
So one last question, Maxime. All right, then let's break for pizza. We have omnivore on the left, vegetarian on the right. On the back right, there's a couple of non-cheese pizzas if you don't do dairy. And on the back left, there is Supreme and Hawaiian. And we'll be back here in 20. Thank you, Maxime.
All right, we're going to get started in just a second. Really quickly, I want to make a small announcement. My name is Jacob Legrone, and I'm a software engineer here at Datadog. I work on the workflow engine team, and we gave a few talks at the Replay conference a few weeks ago about our work. But we are hiring right now, so if you're interested, please reach out to me on the Temporal Slack. It's at jlegrone if you're interested in working on Temporal stuff full time. And feel free to chat with me here tonight if you want to hear about what we do. Thanks. And then I'm going to hand it over to Lauren.
Temporal is also hiring. Go to Temporal.io. Although we have a bad habit of like hiring the evangelists within a company to work at Temporal, and then we don't have any evangelists left at the company. So it's a trade-off. I'd like to introduce Alan George, engineering manager on the Datadog's workflow product team.
Hi everyone. That's very loud. Hi everyone, my name is Alan. As just introduced, I'm the EM on the workflow automation team at Datadog. And so we'll be talking about workflows again, but actually in a very different context here. So first, I'm going to talk about what exactly is workflow automation and how does it relate to Temporal, right? So we'll talk a little bit about that, just give you the lay of the land there, and then talk a little bit about experiences developing on top of Temporal. So hopefully you have all heard of Datadog before arriving at this office, but in case you haven't, Datadog is an observability company. What we do is we allow you to take all of the metrics, the data from your systems. We allow you to generate some sort of insights from it. The most common insights that you would generate are monitors and let's say security signals, and then hopefully you'll be able to respond to those insights. Now, me, like back in the day, like I had a phone, like I was hooked up to PagerDuty, and trust me, like that was the way that I got introduced to Datadog. But when we talk about response, right, like we aren't just talking about getting pages. What we want is for an ability to have like a richer response, maybe even an automated response like based on the telemetry and the signals that we are getting within Datadog. And that's where workflow automation comes in. And our vision, what we're aiming for is the ability for you to, take some of those signals, take that telemetry, and, build a workflow that you want to execute, right? So be able to put together a DAG and encode some of the work that you're doing manually, and say like allow other people to be able to execute it, or maybe execute it in response to a signal. And what we're doing is we're initially targeting the SRE and security markets because we believe that those are the markets in which we have the most experience, and those are the markets that we have the most sympathy with in many ways. Now, what are the features that the workflow automation product provides? I'll kind of burn through this as quickly as possible. Honestly, workflows, the executions that you want to provide are very complicated. So we want to have the flexibility for you to express your business logic. Essentially, think of workflows as like a visual programming language. I think that's fairly straightforward. The next thing is that Datadog prides itself on the depth of the integrations that we provide. Right? I think we mentioned a little bit earlier that we have 400 different integrations. The integrations that the workflow product provides are a little bit more granular. We call them actions. Those allow you to make modifications in your systems. We have over 300 plus actions. We have a lot of actions from cloud providers, PagerDuty, as I mentioned earlier, collab integrations, and even more generic integrations like HTTP and JavaScript. So you can integrate with systems that we don't currently support right now. I mentioned a little bit about responding to signals, right? So I mentioned that signals can be monitors, but in addition, Datadog is trying to enrich and come up with more and more signals. So we have security signals, so the ability to respond to, let's say, breaches or other observed problems in your data center. We have cloud cost management. We allow you to integrate into dashboards and a lot more. We're deepening our integration into Datadog, the product. And then finally, I want to talk about security and access control. At its simplest, workflows can be executed from anywhere, but we know that people have very, very sensitive resources and very sensitive actions they want to provide. So we have tried to come up with both, the ability to securely store any credentials that you require, as well as provide some sort of granular access that you need to restrict who can run workflows and when they can run workflows. So that's a very quick overview of the workflow automation product in general, right? I didn't want to spend a massive amount of time on it, but I wanted to talk about some of the thought process that we went through and some of the lessons we learned in building this product. And of course, as you can imagine, this involves Temporal. So let's say that you are going to go off and build your own workflows product. What exactly would you have to think about? First, we have to start from the user's perspective, right? And many of our customers are arbitrary DAGs. You have to think about integrations. Many of them want to integrate with both on-prem and SaaS resources. And of course, we don't expect things to work successfully all the time. So at the very minimum, you need to have some sort of visibility into workflow executions. Now on the flip side, we've got to think about our own experience writing this product, because this isn't just something that we're just going to write once and then ship out to the world and never maintain, right? We at Datadog pride ourselves on delivering a product that will stand the test of time and that will be reliable and scalable and support you. So we need an architecture that allows us to iterate fast, right? That is going to allow us to deepen that pool of actions that we were talking about, and that will allow us to scale out reliably and effectively for our large customer base. So what's the answer to this problem? And really it is, as you can imagine, use Temporal, right? Like Temporal is really the fastest way to build a workflows product, right? I mean, it is tailor-made for this use case, right? It provides a way for us to, I mean, in many ways, it like abstracts away, as Maxim was talking about, like all of the things that you would have to think about. Like you would have to think about queues, events, like you have to think about scaling. You can't just forget all of that, but it makes the problem a lot easier to handle. The one important thing for us also is that it allows us to iterate fast on our product requirements, right? Because nobody necessarily wants to be thinking about, well, in order to make this change, I have to, like add these two SQS and do this and do that, right? You really just care about, I want to make this product change and I want to do it as fast as possible. So we know that Temporal is like one piece of that architecture. For us, the other thing is that there's a little bit of like inception thing going on here. We have our own workflow running inside a temporal workflow, right? And so we kind of model our workflow in, just very loosely call this a state machine. So we essentially built our own state machine that runs inside a temporal workflow. I want to be very clear here, we're not modeling every single customer's like DAG as a temporal workflow that runs, right? That's not what happens. The other thing that's here is this event store. Temporal does have events. It stores events in Cassandra, right? But it's at a completely different level of granularity than what our customers expect, right? They don't want to see like, activity schedules, activity started, like they want to know like, hey, like this step in my DAG, it ran, right? It's running right now. Oh, it failed, right? That's really what they want to know. So we have to come up with our own abstraction and be able to use this event store to support like debugging, to be able to support any like access controls we need and so on. And then finally, we have our own integration platform, right? Like this is something that we have to be able to iterate at a completely different cadence from the rest of this, like the left half of the system, right? You can imagine that the number of actions that we have to deliver have to be delivered much faster and with a much larger team than anything on this side. Now, this is where I want to make a plug for another team at Datadog. We're actually not just building on vanilla temporal. We're building on something that's provided to us by the workflow engine team. You saw Jacob Legrone up here. He's one of the software engineers on the team. And they have provided a few pieces to us to abstract away some of the minutiae of building temporal workflows, and especially temporal workflows at Datadog. They have done some stuff that, encodes the best practices that we have learned building many temporal workflows at Datadog. So we use the worker framework that kind of abstracts away the, the bootstrapping of getting workers running in the Datadog environment. And we also use the protobuf SDK. There is a great talk that Jacob has done that's available for everybody to see. I think it was at Replay last year, talking about both of these pieces in more detail. All right, so I want to talk a little bit about structuring workflows, right? So when we talked about the fact that in many ways we are modeling our customers' workflows kind of within like a Datadog state machine, ideally we want to just run this as a simple temporal workflow, right? Like this would be the simplest thing for us to think about. But there were some like challenges in our way. Like specifically the most important challenge that we faced was that there was a 50K history limit on a single workflow. And for reasons that are a little too involved to get into, we can't actually support continuous new, right, for this workflow, right? Or it's not that we can't, it's just like fairly involved for us to do so, right? The other thing is that we knew that although we had a certain set of business requirements to start, it was very clear that we were going to have much more business requirements in the future, right? And it's actually quite hard to reason from code, like the code that we're reasoning about, like that we want to build, to the number of events that are going to be generated in event history, right? So what we ended up doing was we actually ended up taking our problem and decomposing it into a set of workflows. So we have like this parent workflow over here, and then we have a set of child workflows that operate at completely different cadences that do support continuous view, and can like allow us to scale and support the business requirements that we thought we had to deal with. This had a number of advantages as well. For one thing, operationally wise, we actually have different workers for each one of these different child workflows. You don't have to do that. There are companies that will bundle all of this into a single binary. We chose to use 3, right, or 4, or however many may be. So it has like different like failure domains, different scaling domains, and so on. The next thing I wanted to talk about is some of the lessons that we learned in terms of like activity options and retries. Activity options are just timeouts and retries. So Temporal has a very, very powerful mechanism of specifying like how long interactions with external systems can run and what to do in the face of failures. Right? And one of the things that we did at the start was that everybody was interacting with external systems. We allowed them to just kind of like pick and choose and arbitrarily say, okay, I want to, I want to use this much timeout, I wanted to use this many retries, and so on. The problem is that over time, people join the project, they leave the project, decisions are lost to the sands of time, and then you come back and you're like, why was this chosen, right? And it often got very, very hard for us to work backwards and say, actually, the reason why we chose this set of timeouts and retries was because this external system behaved like this at this point in time. It no longer does that now, so we can just move and refactor all of this code. What we've done now is that this is just standard software engineering practice, right? Nothing super crazy here. What we're trying to do now is that we're trying to bucket our interactions with external systems into just like classes of interactions, right? We're saying, okay, this system, we know it's a short-running activity. We know that we have to support. It can be retried X number of times. It's not a problem. We know that, whatever the case may be. But what it allows us to do, it allows us to get like a vocabulary for how to interact with these external systems. And we've become very disciplined about this. So we went from every activity having its own set of bespoke options to I think 3 or 4 in our entire system. And so now what happens is that whenever somebody wants to interact with an external system, we're like, what kind of interaction class is it, right? Can you use a set of activity options that already exist? If no, tell us why, right? Should we restructure this external system to support something that we have, make it easier to reason about? Should we come up with a completely different set of retry and activity options? What should we do? Now, this may seem like a simple thing, but you would be surprised at how many bugs we have come up with people misunderstanding the temporal, different timeouts and so on, right? I will show a slide on the next slide of talking a little bit about this. But before I move on, I just wanted to tell you one thing. Remember that retry policies are a trade-off, right? You're trading off the amount of time you're willing to let, in our case, a customer's workflow just stall, right? Versus how long you need to actually mitigate whatever problem it is that's under the hood, right? So really, really think about what kind of retry policies you're putting in place. I strongly suggest running repeated game days, right? Take down parts of your system, see how your workflows react to it. You'd be surprised at what failure modes crop up, right? We talked a little bit about activity timeouts. This is a great blog post that was based on a talk that Maxim gave, right? I think this diagram has basically everything that you need to know about temporal timeouts, right? You'd be surprised at how many times people have forgotten to include one or more of these, right? Resulting in unexpected behavior in your system, in our systems. Feature flags. So this was actually another surprising problem, well, not problem, like challenge that we came up with. We use feature flags a lot, right? We have to do incremental rollouts. We have to turn certain features on and off for certain design partners, for example. And we want to do this in our production systems, right? At the same time, what we want to do is we want to do so without a lot of ceremony. And if we were to essentially resolve our feature flags inline in our workflow, basically we'd have to have an activity, we'd have to, because we're using the protobuf SDK, we'd have to have protos, think about retry policies, maybe do some versioning. It just feels like a lot of ceremony for us, right? So what we went with was a slightly simpler approach, which is basically we resolve a set of feature flags in advance, right? We ship it as part of the input. The input is now frozen in time, right? And it's just like shipped off to our temporal workflow, right? Now that means that in the face of the worker crashes or anything, like this is like trivially replayable, right? Like nobody can do anything like in our external feature flag system to change what value of the feature flag is coming back as. It was resolved ahead of time, right? Nothing is going to change, and there aren't going to be any like versioning or like non-determinism problems. Of course, if you were to remove some certain code paths from the system, you do need versioning, right? Like that, it doesn't remove that, but this has been very, very powerful for us. And then finally, I'm going to talk about versioning just very briefly, right? Like Temporal has an opinionated approach to change management, and that has worked out for us, right? That we totally understand it. We have to do a lot of process, I would say, to make sure that we don't accidentally introduce any non-deterministic behavior. Right? So we do extensive code reviews. That's like step one. Everybody in the team, when they join, has to work on Temporal. Right? There are no people who don't work on Temporal on like the temporal portion of the code, right? Like we support a number of services, Temporal is one of them, and one of their, tasks is you have to write some code that involves versioning, and you have to understand everything about how to work it. We also do like stage rollouts, right? Like you have, it's not just staging for us, like we are doing like, across our data centers. We're very, very careful about how we're doing rollouts. We're doing monitor gates, right? If any alarm trips, right, and we do have alarms on this, right? If any alarm trips anywhere along the way, we just halt the rollout, right? We have like smoke tests. We have a bunch of things to ensure that we aren't introducing non-deterministic changes. In fact, we explicitly have long-running workflows so that when we do our deploys, right, we are guaranteed that we are in the middle of some long-running workflow that has to be started and replayed, right, when we are doing this rollout, right? We don't run short-running workflows only. And now we are currently implementing replay tests, right? So inside our CI/CD, like we are going to do replay tests, and we're also going to do the same sort of upgrade test to make sure that we are able to move on without any non-deterministic behavior. However, we have noticed that there are some surprising sources of non-determinism. We talked a little bit with the workflow engine team about supporting like declarative validation of protos, right? So, we want to say something like, oh, this string is a valid UUID, and like, hey, I want this integer field to be within a certain range. That generates a bunch of code, right? And basically, when you want to validate that code, maybe you call a validate all function from somewhere within your workflow, right? What happens if somebody changes that validation annotation? Within your workflow, you don't see any change whatsoever. Nothing changed, right? But you could suddenly introduce non-determinism because some input that was previously valid has now flipped to invalid or vice versa, right? So this is something that you have to research. If you have some interceptors and you happen to change the behavior and some input that was previously valid is invalid, again, it doesn't seem like it's in your workflow, but suddenly some execution doesn't work anymore. And finally, if you're in like a mono repo or you're depending on a bunch of like external libraries like every one of us does. What happens if the library's API doesn't change, but something semantically inside does change, right? Like maybe they fixed a bug and some previous input suddenly fails, right? Again, surprising source of non-determinism. This can be very, very hard to track down, right? We have sometimes been very fortunate that when we look at the temporal UI, we look at the source of non-determinism, we're like, oh, it's super obvious, like we made this mistake here. And sometimes we've been like, we can't figure it out. Like there's literally nothing in our workflow code that has changed, not around a deploy, don't know what it is. And so then this is where I think it's really important, having set up your replay test, having that infrastructure already in place, ready to go, is going to be incredibly helpful. So those are a few lessons that I wanted to share from us, working with Temporal. In general, I have to say that our experience with Temporal has been very, very solid, right? We started this because we thought it was going to be the fastest way to build and deliver a workflow engine product to our users. We are still incredibly convinced about that. We're very happy in building on top of Temporal. And hell, if you have a workflow engine or workflow product that you want to build, use Temporal. Thank you. Yes.
You mentioned that you tried to identify patterns of activity interactions.
Yes.
And how many buckets did you end up with? How many different patterns and then how many were in the other bucket?
So for us, we ended up with around, I would say, 3, maybe 4, right? I think we have really tried to avoid the other bucket by not just accepting that the systems that we're interacting with are fixed, right? So what we do is that we try to work, honestly, we can work with other teams and say, hey, this pattern of interaction is not great. Can we change something about our contract to make it easier to handle, right? There are a few others, right? But it's not major, and we are actively trying to reduce that number. Right? So 3 or 4 is the short answer with 1 or 2 stragglers.
Do we have one more question for Alan?
Yes.
How are you feeling about the strength of replay tests as a tool to help you manage these non-determinism issues? Are the replay tests themselves deterministic? Do you struggle with branching or cases where you think you have a replay for a workflow or a workflow type, but it doesn't detect things, or is it just too early days and that's TBD?
It's honestly too early because we're in the process of implementing this, right? I think, we're very hopeful, but I would say ask me again in 2 weeks, right? That's the honest answer.
We get a round of applause for Alan. Thanks so much for sharing.